Hi, this is Dale Rhoda, and in this presentation I want to give you an introduction to survey weights. I want to cover them conceptually using some visuals. This movie's just a little bit longer than some of the others in this series, but I think it will be helpful for us to be on the same page about what the weights represent. Let's think first of all of this small population of 30 kids. If we selected 2 children at random from this population, and if we interviewed them to check their vaccination status, maybe these 2 kids would be selected. They each had the same probability of being selected from the population, and so they would carry the same weight. They represent the same number of kids in the population when we do the calculation. So maybe we would find that one of those children was vaccinated and one of those children was not vaccinated. And I like to use a seesaw as a visual illustration for a weighted average. We're going to calculate a weighted average here of coverage. They have the same weight because they have the same probability of selection, and so the weighted coverage is the point where the seesaw would balance. In this case, the weighted coverage, because one of them was vaccinated and one of them was not, would be 50%. 1 out of 2 kids was vaccinated. But let's pick a different sampling scheme. Let's say that in this case we're going to select 1 child from the top tier and we're going to select 1 child from the bottom 2 tiers put together. So the child that's selected on the top, now they have a probability of selection of 1 over 10, and we often say that the survey weight, the base weight, is 1 over the probability of selection, so their weight will be 10 weight units. And the child that's selected from the bottom will have a probability of 1 over 20, so their weight will be 20. So the weight of the child that's selected from the bottom will be twice as large as the weight of the child that's selected from the top. Well, if it happened to be those same 2 kids, and once again we found that one was vaccinated and the other was not, well, now we know that the one that was vaccinated, in this case, we're going to give them twice the weight as the other child. And so now the weighted estimate of coverage, it shifts from 50% up to 2/3, because this child represents 2/3 of the kids in the population, and this child represents 1/3 of the kids in the population. And that's what the survey weight means. It's the proportion of children in the overall population that the selected children, the interviewed and surveyed children, that they represent. Let's look at a bigger example. Here we've got a population of about 137 kids, and we select 13 of them. We select the colored ones here. So in this case, the probability of selection for each child is about 13 over 137. Each child's weight is about 10.5, and the kids have, let's say they have equal weight. Well, let's say that we find that 7 of them are vaccinated. These kids were vaccinated, and so we're going to count them as giving them a value of 100, and 6 of the kids are not vaccinated, so we give them a value of 0, and then we're going to average 700 with 0. 7 over 13 is going to give us an estimated coverage of 53.8%. That's what we would estimate if we selected 13 kids at random from this population with equal probability. But now let's do another sampling scheme, and let's say that we're going to select 1 child from each of these boxes. Okay, so the kids, for instance, in this top box, there are 11 kids in the top box. We're going to select 1 of them, and so that child is going to have a probability of selection of 1 over 11. They're going to carry a weight of 11. In these smaller boxes, we're selecting 1 out of 2 kids. This kid is going to carry a weight of 2, which is much smaller than 11. So now we have unequal probability of selection. Look in these big boxes. The probability of selection here is about 1 out of 30. So the child represented from this box is going to represent 30 kids in the population. So the weights in this data set, they vary from 2 up to 30. If it turns out that the kids in these boxes, the gray boxes, are the ones who turn out to be vaccinated, and the ones in the white boxes are the ones who turn out not to be vaccinated, well, now we have a different story. It's still 7 vaccinated kids and 6 unvaccinated kids, but the unvaccinated kids, they represent many more. Now I've scaled up the boxes to be proportional to the size of the number of kids they represent. The unvaccinated kids, they represent the large parts of the population here, and you can see that the vaccinated kids, they represent the smaller boxes. they represent fewer kids. And so if we use this seesaw analogy here, and we make the boxes on the left-hand side proportional to the number of kids the unvaccinated kids represent, and these proportional to the number of kids the vaccinated kids represent, then the place where the seesaw balances, that's going to be our weighted coverage estimate, and it turns out to be way down here at 28%. It's still 7 vaccinated kids, 6 unvaccinated kids, but because of the differences in probability of selection and the differences in the number of children in the population that each represents, weighted coverage is substantially different than what we saw a moment ago when they were all given equal weight. So the notion of varying survey weights, it has to do with the fact that the probability, it has to do primarily with the fact that the probability of selection is different from child to child. Now, if you looked closely at that last box, there was one little box here where none of the kids was selected. This could be some non-response. And so there is an element, which we'll talk more about later in the course, there's an element of after you assign the weight that's associated with probability of selection, there's an element of the weight that has to do with non-response. Here we need to take the weight that would have been allocated to whichever child was selected here, but because they didn't respond, we need to allocate that weight to someone who did respond in the survey. We need these kids to be represented, and so we need to allocate the weight from those who didn't respond to someone who did. And different people, you could have different ways of doing this. You could reasonably disagree about how to do this. We could just say, well, 28.1% of the other kids were vaccinated. Let's assume that 28.1% of these kids were vaccinated also, and we could assign coverage that way. Or we could say, hey, this is a small little box, and in our experience it looks like the kids in the small boxes, they are much more likely to be vaccinated than the kids in the big boxes. So we could give a weight of that's higher than 28.1%. So we could allocate their coverage in different ways to the vaccinated and the unvaccinated groups. But the conceptual detail here is that we're going to be sure that they are represented in the estimate in some way. That's what we do when we adjust for non-response. So just to sum up here, conceptually, a survey weight it represents the portion of the population that's represented by the respondent, and it varies mostly because the probability of selecting different respondents varies. Now, in the earlier WHO covered survey method, the analysis assumed that every respondent had an equal probability of selection, but that was a simplification, and in many cases that was far from true. And so in the new methods, we correct that simplification, and we try to track the probability of selection and use that to calculate weights to give an improved coverage estimate. The other thing I want you to know, because we're going to use it several times through the course, is that the seesaw, this is a valid computational tool. It's a good metaphor for weighted coverage. You put a block at 100% if the kid's vaccinated, you put it at 0 if they're non-vaccinated, and you make the size of the block proportional to their weight. And then the coverage is the point where the seesaw would balance between the kids at the far left and the kids at the far right. Conceptually, non-response adjustment means that we're going to assign the weight represented by non-respondents to the people who did respond, so that everyone in the population is represented in the calculation. And as I mentioned before, we'll see the seesaws again. So I hope this has been helpful. We look forward to corresponding about this, and we're going to be talking about weights, in different ways through the weeks of the course. So please post your comments and questions here in the update where you found the link to this video, and we'll have some more dialogue about this topic throughout the course. We're really committed to helping you understand all that you want to understand about survey weights. Thanks very much.